Let's say that we have the polynomial p of x, and when expressed in factored form, it is x plus 2 times 2x minus 3 times x minus 4. What we're going to do in this video is use our knowledge of the roots of this polynomial to think about intervals where this polynomial would be positive or negative. And the key realization is that the sign of a polynomial stays the same between consecutive zeros. Let me just draw an arbitrary graph of a polynomial here to make you appreciate why that is true. So x-axis, y-axis. And if I were to draw some arbitrary polynomial like that, you can see that between consecutive zeros, the sign is the same. Between this zero and this zero, the polynomial is positive. Between this zero and this zero, the polynomial is negative. And that's almost intuitively true because if the sign did not stay the same, that means you would have to cross the x-axis. So you would have a zero. But we're saying between consecutive zeros. So between this zero and this zero, it is positive again. Then after that zero, it stays negative. Once again, the only way it wouldn't stay negative is if there were another zero. So now let's go back to this example here. And let me delete this because this is not the graph of p of x, which I have just written down. Let's first think about its zeros. So the zeros are the x values that would either make x plus 2 equals 0, 2x minus 3 equals 0, or x minus 4 equals 0. So first, we can think about, well, what x values would make x plus 2 equal to 0? Well, that, of course, would be x equals negative 2. What x values would make 2x minus 3 equal 0? 2x minus 3 equal to 0. Add 3 to both sides, you get 2x equals 3. Divide both sides by 2, you get x equals 3 halves. And then last but not least, what x values would make x minus 4 equal to 0? Add 4 to both sides, you get x is equal to 4. And so if we were to plot this, it would look something like this. So this is x equals negative 2, x equals negative 1. This is 0. This is 1, 2, 3, and 4. And let me draw the y-axis here. So the y-axis would look something like this. X and y. We have a 0 at x equals negative 2. So our graph will intersect the x-axis there. We have a 0 at x is equal to 3 halves, which is 1 1/2, which is right over there. And we have a 0 at x equals 4, which is right over there. And so we have several candidate intervals. And actually, let me write this down in a table. So the intervals over which, and this is really be between consecutive zeros, intervals to consider. So I'll draw a little table here. So you have x is less than negative 2. That's one interval. X is less than, actually let me color code this. So if I were to say the interval for x is less than negative 2, so that's this yellow that I draw at the extreme left there. We could have an interval where x is between negative 2 and 3 halves. So negative 2 is less than x is less than positive 3 halves. That would be this interval right over here. You have the interval, I'm trying to use all my colors, between 3 halves and 4, this interval here. So that would be 3 halves is less than x is less than 4. And then last but not least, you have the interval where x is greater than 4. That interval right over there. So x is greater than 4. Now, there's a couple of ways of thinking about whether over that interval our function is positive or negative. One method is to just evaluate our function at a point in the interval. And if it's positive, well, that means that that whole interval is positive. If it's negative, that means that the whole interval is negative. And once again, it's intuitive because if for whatever reason it were to switch, we would have another 0. I know I keep saying that. But another way to think about it is, over that interval, what is the behavior of x plus 2, 2x minus 3, and x minus 4? Think about whether they're positive or negative, and use our knowledge of multiplying positives and negatives together to figure out whether we're dealing with a positive or negative. So let's do it. We can do it both ways. So let's think of this as our sample x value. And then let's see what we can intuit about or deduce about whether over that interval we are positive or negative. So for x is less than negative 2, maybe an easy one or an obvious one to use. It could be any value where x is less than negative 2. But let's try x is equal to negative 3. So you could try to evaluate p of negative 3. You could just evaluate that. Actually, let's just do that. So that's going to be equal to negative 1 times 2 times negative 3 is negative 6 minus 3 is negative 9. Negative 9 times negative 3 minus 4, that is negative 7. So if you were to multiply all of this out, this would give you negative 63, which is clearly negative. So over this interval right over here, our polynomial is going to be negative. So then we can move on to the next one. And an interesting thing is we didn't even have to figure out the 63 part. We can just see that there's a negative times a negative times a negative, which is going to be a negative. And so let's just do that going forward. Let's just think about whether each of these are going to be positive or negative and what would happen when you multiply those positive and negatives together. Now in this second interval between negative 2 and 3/2, what is going to happen? Well, we could do a sample point. Let's say x is equal to 0. That might be pretty straightforward. Well, when x is equal to 0, we're going to be dealing with a positive times a negative times a negative. A positive times a negative times a negative. And the reason why I did that, I just did in my head, I said, okay, that's going to be a positive 2 times a negative 3 times a negative 4. So a positive times a negative times a negative. So I could write it this way. It's going to be a positive times a negative times a negative. Well, a negative times a negative is a positive, and a positive times a positive is a positive. So we are positive over that interval. And if you were to evaluate p of 0, you will get a positive value. Now what about this next interval? What about this next interval here between 3/2 and 4? We could try x is equal to 2. When x is equal to 2, we are going to get a positive times a positive times a 2 minus 4 is negative times a negative. So this is going to be negative over that interval. And then last but not least, when x is greater than 4, we could try x is equal to, let's say, 5. We are going to have a positive times a positive times a positive. So we are going to have a positive. And as I mentioned, you could also do it without the sample points. You could say, okay, when x is greater than 4, you could say, okay, for any x greater than 4, if you add 2 to it, that for sure is going to be positive. For any x greater than 4, if you multiply it by 2 and subtract 3, well, that's still going to be positive because 2 times something greater than 4 is definitely greater than 3. And for any x greater than 4, if you subtract 4 from it, you're still going to have a positive value. So that's another way to think about it, even if you don't use a sample point. But there you have it. We've figured out the intervals over which the function is negative or positive. And we don't know exactly what the function looks like, but generally speaking, it's negative over this first interval, so it might look something like this. It's positive over that next interval, and then it's negative over that third interval, and then it's positive over that last interval. So it would have a general shape like this. We don't know, without trying out more points, exactly how high or low it would actually go.